Hello guys, welcome to my channel. So today we are going to talk about most commonly asked core Java interview questions. So in this video we are going to work on a lot of questions theoretically and practically. So before we work on that, if you are new to my channel, if you haven't yet subscribed to my channel yet, please do. I see that a lot of people are watching my videos but not yet subscribing, so please do that. Talking about core Java interview questions, so first question would be your interface versus abstract class. So this is a very common question and it's a very basic question as well, but a lot of people get confused because they don't know when to use which, right? So an interface is a reference type in Java containing only constant method signature, default method, static method and nested type. Interfaces cannot contain instance field or constructors. So here the key thing to know is that we have function interface, we have interface, but they both are interface. And the core functionality of using an interface is to provide loose coupling, right? So we cannot create an instance of an interface. We shouldn't have a functionality within your interface. It only has non-abstract method, along with we can have default methods and static methods. So that is your interface, right? Now where to use it? So it defines a contract that other classes must follow. An interface specifies what a class must do but not how it does it. So this is basic definition of abstraction. So here we just provide a single responsibility, and every class that implement that interface or override, in that case it has to follow the same pattern, right? Along with it we can have inheritance also. So a class can implement multiple interfaces, providing a way to achieve multiple inheritance, which is actually prohibited in Java. Now data members, an interface cannot have instance field. All variables in interface are implicitly public, static and final, so they are constant. Talking about access modifiers, methods in an interface are implicitly public. If you don't provide public, it will be public, right? But from Java onwards, interfaces can also have private methods. So remember that if an interviewer asks you that can we have private methods in an interface, if you say no, then that is not true, because from Java 9 onwards it can have private methods. Now constructor, there is no use of having a constructor because you won't be creating an instance of an interface, so why use it? State interface cannot maintain state because they have constant, abstract constant, and classes that will inherit these interfaces have to maintain state, right? So this is all about interface. Now abstract class actually is a class which cannot be instantiated again on its own, and same is the case for interface, right? This may contain abstract method, which means that you can have abstract as well as non-abstract method, which commonly known as no concrete methods. Now talking about usage, it is used when you provide a common base class, and you can so if you want to implement a lot of design pattern which we have in Gangs of 4, abstract class and interfaces are commonly used there. So abstract class provides a functionality where you have a base class and then you have some shareable methods. Those methods will be used by the subclasses, and actually this is overriding. Now talking about inheritance, a class can extend only one abstract class. This is a restriction because Java doesn't provide multiple inheritance, but you can use multiple inheritance using interface. So this is one difference. If you want to use multiple inheritance, you can use interfaces, otherwise abstract class is the way. Now data members, an abstract class can have fields and constructors. It can also have method implementations, but remember that if it has constructor, this doesn't mean that you can instantiate. You cannot, but you can call your super constructor using your subclasses, right? So that is one functionality. Now access modifier, abstract class can have public, protected, private. So yeah, that is that. Constructor, you can have constructor, which we already talked about. Talking about state, yes, it can have state because it has fields which are not constant, and you can have multiple access modifier. Now to summarize, use an abstract class when you want to share code among several closely related classes. Remember, we are talking about method with a body, and when you want to provide a base class that contains default behavior. You have to use an interface when you want to define a contract for what a class can do but not how it does it, because you will provide a method with no functionality, and when you want to take advantage of multiple inheritance. Alright, so now let's understand the basic difference between abstract class and interface using an example. So let's create an abstract class first, and let's see what we can do and what we cannot do. So let's name this class as abstract test abstract. Okay, and this is a public class. So alright, so now it is an abstract class. So what we can do is we can have abstract method and non-abstract method. Also we can have a main method. So if I do something like this, so let's say hello, and if I run this, so I'm able to run it. So also check this one out, that the order here of abstract can be like this also, and in that case even it will work. So you can swap the order in any way you want. Alright, now what can we have actually is your abstract method. So let's say public void, and the method name is abstract method. So here you need to provide you don't need to provide a body in the abstract case, but for the case of non-abstract case you have to provide something. So let's say hello from non-abstract method, and this one will be like this. Then we can have an abstract method. So public abstract void abstract method, and here this will be something like this. Now like I said, we cannot create an instance of this class, so let's try to create this. So text abstract ta equals to new text abstract. Now let's remove this overridden thing, we don't need that right now. So now check this out, are we able to create an object? We are getting a compilation error, and the error says that the test abstract class is abstract, it cannot be instantiated. One thing clear, that we cannot have an instance of an abstract class, but we can have a main method. Now let's work on an interface. So interface, and done. So interface can have only non-abstract method, only abstract method, and it cannot have non-abstract method. So if I try to have a method like this, so here what you see, interface abstract methods cannot have body, but we can have default and static methods. So here if you see, we have a method here as default, and then we have a static method, right? Here you can provide any logic you want. So hello, and here let's do welcome. So here you are able to provide the logic, right? But can we have a main method here in interface? No. Now here if you see, we are not getting any compilation error, right? So let's try to print something here, hello from main, and now let's run this. So here you can see that we have the output. So right now I'm using Java version 21, and before Java 8 you wouldn't be able to put any static methods in an interface. Now because we can have static methods in an interface, so this is also allowed. So that's why you can have main method in an interface. If the question is before Java 8, then say no, but if the question is after Java 8, then say yes. Otherwise you can clear this thing out before answering also, right? So this is all about interface and abstract class. Now let's move on to the next question. Alright, talking about second question, composition, aggregation and association. So not many people know about this because we only talk about 4 OOPS principle, which are your inheritance, abstraction, polymorphism and encapsulation. But these principles are commonly used in every OOP language. So this is basically a functionality which should be known to a developer to provide a better functionality in their code, right? So let's talk about association first. So association is a relationship where all objects have their life cycle and there is no ownership, right? As in there is no class which has to maintain an ownership amongst inheritance or amongst your inherited classes. So this inheritor uses A. So let's take an example. So let's say that you have a teacher class and you have a student class. Now usually in our schools we have a responsibility, as in a teacher has a responsibility of a student, but in this example they can exist independently, as in a teacher can have a student and a student can perform independently. Same is the case for teacher, because your teacher is going to mark your attendance, mark your sheets, basically attend PTM, parent teacher meeting. So this is not actually a complete ownership. This is actually they can perform independent operation, right? So they exist in a same state, they have their own functionalities, responsibilities, but they don't perform with each other, right? They don't. Now when do we use it? So let's say that you have 2 classes which want to communicate with each other, but they don't have any coupling, any dependency in between each other. So they don't know about each other, but you want to define a communication, right? So in that case you can use association. Now aggregation is actually a form of association, but there is a ownership, right? So here we can talk about example, let's say your parent and child. So child can exist independent of your parent, but it has ownership, as in your parent has an ownership, right? So in this case we have has a relationship, like vehicle has 4 wheels, vehicle has 2 wheels. So in this case this is a relationship. Another example is a library has books. Books can exist independently, but they have to be associated in a particular library so that you can find out in which library a book is. So association uses a relationship and aggregation uses hash relationship. So remember that. Now this one is pretty simple, composition. So this is a stronger form of aggregation, not association, right? So in this case it applies applies ownership, but it has a strict dependency between parent and child objects. Now what does it mean? So let's say that you have a parent class and you have a child class. So in case parent class is destroyed or deleted, in that case your child class will also be destroyed. You won't be able to use it. So the usage here is your part of relationship where a child cannot exist without a parent. So we can take an example here. A house has multiple rooms, right? But a room cannot exist without a house because it embodies your rooms. So if a house is destroyed, rooms will be destroyed. So literally this doesn't mean that. So if in case let's say an earthquake is happening, in that case maybe a portion of your house is destroyed but you have some rooms left. Don't take that literally. If you have a house and if you demolish your entire house, then you don't have any rooms. This means that. Okay, now let's summarize this. So talking about dependency, association is independent, aggregation is independent but ownership exists, composition dependent, completely dependent. Okay, so child cannot exist without parent. So remember, in a hierarchy, association is free, aggregation is little free, composition is not free at all. So like that. Now in ownership, association has no ownership, aggregation is weak, and composition is strong ownership. So example we have already talked about. Now overloading versus overriding. So here I am going to talk about method overloading, but remember there is one other question, which is data overloading. So there is nothing known as data overloading, but if someone asks you, don't get confused, this is not simple overloading, this is not simple overriding, right? Now what is method overloading? So method overloading allows a class to have more than one method with the same name but different parameters. So when we talk about parameters, it can have a different access modifier, it can have different number of argument, it can have different return type or different data type, right? It can have integer, string along with it, right? Or different order. So here in this case, this is a compile time polymorphism. Alright, so this is a type of polymorphism and this is a compile type, or you can say static polymorphism. Now where do we use it? So wherever you want to have an increased readability of the program, you should have multiple method and you can have different behavior in it, but remember the name is going to be same and the parameters are going to be different. So it can have different, let's say in one method you have ABC, another one you have DEF. Along with it you can also have int string and string int, different order, right? Now the return type can be same or different, so it doesn't matter. So overloading is basically based on your method signature, which comprises your method name and your argument list. Now inheritance, yes, this is not going to be inherited because this is compile time polymorphism, static polymorphism. And when we say static, it means that you are only talking about a single class. So when we talk about single class, there is no use of inheritance, so inheritance doesn't apply here. But in case of overriding, it does apply. So overriding only happens when you have a parent class and a subclass, right? So method overloading allows a subclass to provide a simple or specific implementation of a method which is already defined in its superclass parent class. Now where do we use it? So wherever you want a runtime polymorphism or dynamic polymorphism, you want to modify your parent method behavior in your inherited class, there you can use it. Now here the return type does matter and return type should be same or subtype of the return type. So let's take an example. So let's say that you have a return type in your parent class as object. Now in your subclass you can have the return type as anything, because every class extend object class, right? So it is a parent, object class is a parent. Now inheritance, yes, it applies because here we are involving two classes which are using inheritance. Talking about annotation, this is completely up to you. If you want to use it, you can use it, otherwise don't, right? So this is override annotation. Access modifier, so here we have a dependency. So if you have, let's say, private in your parent class, then you cannot override it because it's not possible. Private belongs to the own class. Now if you have let's say public, then you cannot restrict it more than that, because public is really free, so you can only use public, but you can swap between protected, default and public, right? So this is that. So if let's say your parent class has protected, then you can use public in your subclass. This is an example. Alright, so let's summarize. The purpose of using overloading is to have multiple methods with the same name but different arguments. Overriding to change the implementation of your parent class method. Okay. Method signature, overloading should have a different argument list and nothing matters. So method signature is the main key here. Talking about overriding, it should have exactly same as whatever defined in your parent class. Now this is overloading is your compile time polymorphism, overriding is runtime. Inheritance, overloading doesn't use inheritance, overriding does. Return type, overloading in that case it doesn't matter, but in overriding it does matter, and it has to be a covariant return type. Now let's take an example of overloading first. So I'll create a new class for this. Alright, so here what do we need basically is we need a method that we can overload, right? So first thing first, let's have a main method, and then we can have other methods. So let's say that you have a method to add two numbers. So here you will have two variables, int a comma int b, and here you are simply returning a plus b. That's it. Now I can overload this method in few ways. First way is that I can have the return type as double, so something like this. In that case I will use double on a, double on b. Now what else can I have? I can have different number of arguments as well. So here int c and here plus c. Now let's try to change the order from a to b to c, right? Let's see. So here if you see it says int comma int comma int is already defined. So if you change the order here, it won't matter. So it will ask us that provide something else. Now what I can do is I can try this from int to double, and I'll just remove this c from here. And here I'll do double. Now in that case it is not telling me that provide any other method, because here you have double, here you have double int, right? Two different types, and if you call them from main method, then obviously they will work. Now let's take an example of your overriding. So let me create another class. So I'll use this main class I'll use this main class for the execution, and then I'll create a parent class first and then child classes, because we need inheritance here. So here I will just have a simple method make sound, and here I'll just do animal makes a sound. Alright, nothing else. Now let's create another class. So dog. Here also you will have a method with the same kind of a logic. So public void make sound, right? And here if you see, you already have the override annotation here. So if you remove it, there is no problem, but it's better to have override annotation because it's more readable in that case. Now I can do a simple calling something like this, or I can try to print something else. Let's say dog barks. Alright, now I can have another subclass, let's say cat, and here also it will extend animal and make sound, and here let's say cat meows. Alright, now let's come back to main, remove everything from here, and what I will do is I will create an object of dog. See, I'm not actually creating the animal object, I'm creating the dog object and then assigning it to an animal object because I can, right? That is what inheritance is. Now similarly I can have another object my cat and new cat. then I will just do my dog dot make sound, and again my cat dot make sound. Let's run this. Alright, so it printed everything out. Now let's understand more towards our overriding. So in animal we have a method make sound, in in dog we have the same, and then in cat. What if we had an argument? So now what if we had an argument here? So if let's say if I have int a, though I'm not using it, but if I come back here, you see there is a problem. So here I need to provide int a as well. Again here I need to provide int a. So now to call them you need to provide any argument that you like. So I am providing 1 1, that's okay. Now what if I try to change the return type here? So let's say string. Here I'll just return null for now. So nothing changes much here, but here also I need to change the return type like this, right? Now if the return type is something like this object, then I could have something like this, and see it is going to work. So I'm not actually using the same return type, I'm using the covariant return type here, and there is no problem with it. So if I run this now, same output. Alright, now what else? Let's say if this is public and if I try to make it protected, what happens? We get an error, and error says that make sound clashes with make int attempting to assign weaker access privilege was public. What if it was vice versa? What if we had protected here and public here? Are we getting any error? No, we are not. So you cannot provide any weaker restriction, right? So you have to provide the access modifier in a way that you provide more visibility in your child class, or same visibility. If you have protected here also, then this will work, and here we have public, so obviously this is going to work. So this was all about overloading and overriding. Now let's move on to the next question. So the next question is, can private method or static methods be overridden in Java? So this is a tricky question. There is no straight answer for it. So if you let's say say no for this, then you will be asked a lot more questions. So yeah, now let's talk about private methods. So as you know, private method means that they are private to the class, so they cannot be readable or visible through any other class, so they are not actually accessible. So if they are not visible, then how can you actually override it, right? Now talking about inheritance, since private methods are not visible or not inherited by subclasses, they cannot be overridden. So what is the purpose of having private methods? So private methods are meant for internal use within a class and not intended to be modified by subclasses. So if you want a proper functionality within the class itself, in that case use private methods. Now talking about static methods, so static methods are actually owned by the class, as in they are resolved at compile time. So when we talk about compile time, we cannot work on a dynamic polymorphism, as in your runtime polymorphism. So if all the functionality is within the scope of your compile time, then in that case how can you override, right? So that is why the scope of static methods is limited to the class, and they cannot be called by any other class. Now talking about inheritance, as you know, we are working on a static binding, so they cannot be inherited. So if they cannot be inherited, then they cannot be overridden. So this is the proper answer, but there is another definition. So static methods, when we override them, actually, if you look at the code, let's say if you have a parent class and if you have a child class, in both these classes you have static methods with the same name, with the same arguments, with the same signature, everything, right? In that case, if you look at it, you can say that okay, these methods are actually overriding, but they are actually not, because the methods are hiding. Okay, so this is method hiding, this is not overriding. So if someone asks you what is method hiding, then you can say that if there are two static methods in a parent and child class, then that is called method hiding. Alright, now to summarize, private methods cannot be overridden because they are not accessible or visible to subclasses. Static methods cannot be overridden because they are actually owned by the class. So static method calls are resolved at compile time based on the type of the reference, not the actual object. Next question, why is multiple inheritance not supported? So this is a very basic question, and I have been seeing this question since 10 years or so, and this is a very basic question also. So this is actually a core concept. So this happened in C++ also. There is a problem called as diamond problem, and what this problem says that if you have multiple classes inheriting each other, as in let's say if you have A and B class and there is a C class, and the C class is inheriting from both A and B classes, and in those A and B classes you have a same method, then if you override in the third class as in C class, in that case how would Java know that which method to call when you actually call that same method? So in that case the problem is diamond problem. So this actually leads to ambiguity and conflicts, because of which multiple inheritance is not allowed. Remember, we are talking about classes here, not interfaces, right? Now second problem was that simplicity and maintainability. So Java was actually very simple and readable over C and C++. So allowing multiple inheritance will increase the complexity and it won't be easy to learn. So to maintain that, to avoid multiple inheritance, Java maintains a simpler and cleaner class hierarchy. Third reason is interface inheritance. So Java provides a way to achieve multiple inheritance using interfaces, as I said before. So a class can implement multiple interfaces and not classes. So a class cannot extend multiple classes but can implement multiple interfaces, which allows you to use multiple inheritance if you want to, and this will actually avoid diamond problem, because you don't actually face this issue when you call a method, because in that case interface cannot be instantiated. So you actually call using your subclass, actually the class which is inheriting from those interfaces. So this issue will not occur. So that is that. The fourth reason is code reusability. So this was the one of the core principle behind creating Java. So Java encourages composition over inheritance. So if you are using inheritance, in that case there will be some issues, right? But if you focus on composition, in that case you will focus on code reusability. So this means that a class can have instances of another classes and delegate functionality to the subclasses or to those instances. Alright, let's summarize this. So why don't we have multiple inheritance? Because we want to avoid ambiguity, we want to have a simple design, we want to use interfaces, also to use loose coupling, we want to promote composition over inheritance. So these are the reasons. Now very common and very vast question, how string pool works. So this is a very vast question. There are going to be a lot of sub question. So if you understand the functionality, then you will be able to answer every question behind string pool. So let's understand what string constant pool is. So string constant pool is basically a pool or an area particularly created for your string objects. So we have two type of string basically. One is your literal, another one is your object. So we create literal using your equals operator, we create a new string using your new keyword. Now talking about string literals, when you create a string using double quotes, as in string as equals to hello, in that case JVM checks the string constant pool to find out if hello is already there or not. So if hello is already there, in that case the Java or JVM will not actually create another hello, it will actually refer hello object to S or S1, whatever naming you are using. Now what functionality are we getting here? What is the advantage? So here we are using strings again and again. We are not creating strings over and over again. And why this happened is because the programmer of Java knew that the string class is going to be used a lot often than any other class, and we actually do that. We create a lot of string variables in our code, so we don't want to fill up the memory pretty easily, and the Java garbage collection doesn't happen immediately. So even if you call garbage collector on your own, then there is no guarantee that the objects will be cleaned up immediately. So there is no guarantee. You can try a lot of ways, but again there is no guarantee. So to seek that, programmers decided to have a constant pool specifically for strings, so that we can reuse the same object over and over again. So reusing string is that if you have an identical string existing in the pool, in that case there will be a reference to that existing string and you will be able to create a new instance. Now talking about new string, if there is nothing available as of now, in that case if the string does not exist, then a new string object is created and added to the pool. Now new keyword, when you create a new string using new keyword, in that case two things happen. First is that a new string object is created in the heap memory. Remember, not constant pool, heap memory. And it will not refer to any string in the pool even if an identical string exists there. To ensure that the new string is added to the pool, you can use the intern method, right? So this intern method here comes into the play. Now benefits of using string constant pool. So first, I have already talked about, is your memory efficiency. By reusing string instances, this string constant pool helps to save memory, and this is especially helpful when there are many identical string literals in the code. Performance, you obviously get the performance because it reduces the overhead of creating and garbage collecting new string instances. So remember, how many cycle of garbage collection are running in your application, that matters a lot in terms of performance. Now to summarize, if you are creating string literals, they are automatically placed in the string constant pool. If you are using new keyword, then a new string object will be created in the heap memory. Intern method ensures that the string is added to the pool, returns the reference from the pool if it exists. This applies to when you create a new string using new keyword. Now memory efficiency and performance, so it helps in conserving memory and enhancing performance by reusing existing string instances. Now what are some object class methods? So not many people, I have taken some interviews and not many people know a lot of object methods. Even they get confused when I say that why clone method is an object when we use it through clonable interface. Why do we have wait, notify all in object class when these methods are commonly used in your thread class or thread objects? So these are very basic question, right? So if you know, then object class is your parent class of every class, right? So what are the methods? So key methods, if you talk about, is equals and hash code first. So equals and hash code we commonly use when we talk about map, set, or any other class where you want to have an additional functionality. So equals, why do we use equals? So the name pretty much say everything. So it determines whether two objects are equal or not, and the default implementation checks if the references point to the same object. When I talk about references, I'm not saying memory address, right? Now commonly overridden, so we often override this method in classes to provide meaningful equality logic based on the content of the object. So we will take an example to understand more to it, but right now you know that there is an object class where we have a method equals. So yes, we have to override equals method because every class inherit object class, right? So you don't explicitly say that extend object, you know that it is already extending object. Now hash code, if you don't know, there is a contact between hash code and equals, which you have to Google. There is a hint. This is another very common question. So remember, what is the contract between hash code and equals? Now hash code, the purpose is that it returns a hash code value for an object. The default implementation provides a unique integer based on the object's memory address. There is a formula pre-written in the default functionality. Now commonly overridden, so it often override to maintain the general contract of hash code and equals. Now toString method, so this is very simple. There is nothing to add more to it. This simply says that whatever object you have created, you want to convert it to a string. So that's that. So the purpose is that it returns a string representation of the object. Implementation returns a string that includes the class name and the object's memory address. Now this is the default implementation, you can change it. So whenever we override, we want to provide a meaningful message instead of printing class name and memory address, because that is nowhere meaningful, right? Now clone method, so remember that it throws clone not supported exception right, remember that. Now the purpose is that it creates and returns a copy of the object. Default implementation creates a shallow copy of the object. When we have classes that need to support cloning, they must implement the clonable interface, and clonable interface is a marker interface and it doesn't have a method. Now we have to override this method to provide the cloning logic. Alright, what else? Now we have wait, notify and notify all. So we have overloaded method of wait, and then we have notify all. So depending on your functionality, you can use wait method. So wait method works on a timeout and nanos, and you can use without timeout and nanos. So if you use wait method without any argument, this says that use the current thread to wait until another thread invokes notify or notify all on the same object. And obviously we use this in a multi-threaded environment where we want to have a synchronization between multiple threads. Now wait with timeout, here you will specify a time to which it wants to wait, or if a thread invokes notify all, then also it will resume. Now with timeout and nanos, again same thing, it's just that you will provide additional precision of nanoseconds. Now notify, the name itself specify everything, so it wakes up a waited thread which is actually waiting for something to happen. Now usage, again multi-threaded environment, so providing synchronization, and wait, notify all work together. So that's that. Notify all means that wake every thread that is waiting on the object monitor. Now finalize, so finalize is one of the way to call garbage collector, and this doesn't mean that if you provide explicitly calling of your finalize method, then the garbage collector will happen. This doesn't mean that. So the usage is to perform cleanup operation before the object is removed from memory, right? And here you can see that I have written not recommended for general use. Now the next question is, why is wrapper class required? So you know that we have primitive types and we have wrapper classes in Java, and why do we actually require wrapper classes when we already had primitive? So first is that you need object manipulation, because in Java everything is all around object. So that is why we need object manipulation here. So let's take an example of collections framework. So in your collections framework you have array list, hash map, hash set, and there you actually have to work with objects because you use generics, and generics actually work with only objects and not primitive types. So That's why you actually use object here, and that's where wrapper classes comes into existence. And the sixth reason here is using with generics, and here this also applies. Now primitive types obviously are not objects, so we cannot use them, and just to have a mapping from a primitive type to a class, we have wrapper classes. Now auto boxing and unboxing. So if you don't know about it, it's a very common word and commonly asked in interviews. So wrapper classes facilitate auto boxing, and it means that they will automatically convert your primitive type to wrapper class, right? And same is the case when you want to convert back to your primitive type, and this feature was introduced in Java 5. Now utility method. So let's say that you want to use a utility method to convert strings to their respective primitive type, and vice versa. In that case we want to use wrapper classes because they provide that utility, like toString, toChar, right? So toChar array, and similarly parseInt. So there are a lot of methods. So these are your utility methods. Now default values in collections. So it holds a default value of its own, like for int you will have a default value like 0, but for double you will have value like 0.0d, and for float 0.0f, right? So something like that. So there is no default value other than that. You cannot assign null. That is why we actually come to wrapper class for using null values, and for every wrapper class you can use a null value. So this actually represents the absence of value in collections or any other data structures. Now immutable and thread safe. So primitive types are not actually thread safe, because we are not talking about something on which we can actually put a monitor, or maybe we can synchronize it, right? Because we want to have something whose state we cannot change while we are actually working on it. So talking about immutability, it means that you cannot change the existing value. So in that case you need wrapper classes, and immutability actually prevents the object to be used by multiple threads at the same time, so that becomes thread safe. Now generics we have already talked about. Alright, so this is about your wrapper classes. Now next question, can main method be overloaded? So this question can be asked in multiple contexts. So what do I mean by that? We can have a main method in a simple class, but this question can be asked something like this, like can we have a main method in an abstract class? Can we have a main method in an interface, right? So something like this. But talking about overloading, yes, a main method can be overloaded. So JVM actually looks for a complete method signature, which something has to be public static void main string array, and then the argument name. So argument name, you can use anything, and there are multiple ways to put arguments to this list, but ultimately the method signature, the order has to be something like public static void main. And here I will also tell you about the tweaks that you can do in the order, right? So overloading means that you can change arguments here, right? And you can change the return type, something like that. So that will be your overloaded method. So we will take an example on this. So standard main method is the entry point of the program which JVM looks for, and then you have overloaded main method which gets called by your standard main method. So these are something with the same name but having a different argument or different arguments, so they can be called from your main method. So to summarize, main method can be overloaded. JVM only looks for the standard main method with the signature public static void main. Overloaded main methods will not be called automatically by JVM because you have to explicitly call them. Then overloading the main method can be useful for testing purposes or to demonstrate method overloading concepts. So in real world scenario, I haven't ever overloaded the main method, but maybe you might see that scenario in your project. So for this I will create another main method, and see, for overloading we have already talked about, so I'm going to follow everything up. We don't have the same number of argument and it's working, right? But if I have string but if I have a string a, also this is working. But if I have something like this, then it will not work, because now JVM Java will get confused. So this is that. I can have anything here, it will work, any number of arguments. Also I can change this to public void also, that will also work. And I can change the static the order and keep it here, this will also work. And same will work here as well. So if I do static here, then also it will work. So if I run this, yeah, it's working fine, right? So yes, main method can be overloaded. Now let's move on to the next question. Now, why are strings immutable? So if you don't know that strings are immutable, then yeah, this is going to be a very long answer. But if you know why are strings immutable, then an interviewer can also ask, how can you create an immutable class, right? Your own immutable class. Now strings in Java are immutable, which means that when you create a string object, the state of that object cannot be changed. So there are a lot of reasons for making strings immutable. The first reason is your performance, second is your security, and third is robustness. So additional benefits that we get are thread safety. So we have already talked about this. So immutability means that you cannot change the state of the object. So if you cannot change the state of the object, if any number of threads are using that object, then they can just fetch the value, they cannot change the value, right? So it prevents multiple threading, accessing and changing. So it provides you synchronization without actually doing anything. So yeah, it is thread safe. Now talking about security, so strings are the most commonly used classes, and you use a lot of objects of type string, and you use them for your username, for your password, and for your any configuration. So when we make strings immutable, we cannot change the password, the username. So if a hacker or if someone can actually have the access to your application, then he can see the password, but he cannot actually change the value of that password. So it's not recommended to keep passwords in a simple plain text, right? So you should always use hashing technique or encryption techniques to put a hash value instead of a plain text, right? That's another topic. Now you have string pool. So a string pool provide you memory efficiency. Like if you have a same value or a same string keyword, a word in your string pool, then you won't be seeing multiple words with the same value in your string pool. It will actually use that same word to refer to the new object or new string literal. So what does JVM do is, when you create or when you use a string literal, then JVM first checks the constant pool to see if the same string already exists or not. So if it does not exist, in that case it will create it, but if it does exist, in that case the existing string is reused, and here we get memory efficiency, right? Now we have caching and performance. So caching, why? Because strings are immutable, they can safely cache their hash code, and this makes repeated access to the hash code very fast, which in particularly used in hash based collections like HashMap, HashSet. Now design simplicity. So immutability simplifies the design. Like here you don't have to do anything for synchronization, for memory management. So it provides you a lot of simplicity. and you don't have to worry about the side effects of modifying it, because you cannot, and this leads to fewer bugs and more predictable code behavior. Now, integrity and security in reflection and class loading. So I have asked this question to many candidates, like, if you have an immutable class, how do you actually break it? Because it's easy to use reflection to break immutable class logic. So when you use reflection APIs, so like strings are used in various critical Java APIs such as reflection, class loading, other system level operations. So immutability ensures that string used in these contexts cannot be tampered with, preserving system integrity and security, right? Now, to summarize, it is thread safe, it is secure, it is having string constant pool, it provides you caching and performance, it is actually simple, it provides you integrity and security in reflection and class loading. Now the next question, can abstract class have main methods? Yes, it can have a main method because it's a class. So in Java, the main method is just a static method and there are no restrictions. So yeah, that is that. An abstract class can have a methods. Now to summarize, I don't think we have talked much on this, but again let's summarize. So an abstract class can have main method because the main method is static, and static methods can be included in abstract classes. The main method in an abstract class can be used to test the class or for any other purpose, just like in any other class. So it's a simple class, right? You can have a main method in concrete subclasses also, which can call the methods of this abstract class or implement its own functionality. Now this question is asked when you are working on a multi-threaded environment. That is where you can actually differentiate amongst these three: string, string buffer, string builder. So let's first talk about string. So string is immutable, so it is thread safe. We cannot do any modification to it. Yes, it does provide you a lot of performance because you cannot modify anything. So yeah, so talking about performance, because it is immutable, the performance is not that good because it involves creating multiple string objects. Now talking about thread safety, yes, it is thread safe because it is immutable. Now why do I need string buffer when I had string? So string buffer is mutable. Here you can change values of your string buffer object, and it provides you more performance than string when you want to do any modification, because it doesn't involve creating new object with each modification. So here you get more performance. Now thread safety, string buffer is synchronized on its own, so it is thread safe, but it is slower because it uses a synchronization overhead. Now string builder is completely different. String builder isn't thread safe because it isn't synchronized, and it is best to use it in a single threaded environment. And performance wise, it is generally faster than string buffer because it is not synchronized and there is no synchronization header, so it provides you more performance. It is again mutable, you can change values to it. So yeah, now to summarize, use string when you want immutability and thread safety. So first reasons should be your immutability, that is why we always use string. If you want to use performance over everything on string, then use string buffer. Like you can use file and create a string buffer object on that. Use string builder, and you can actually use string buffer in a multi-threaded environment. If you don't have a multi-threaded environment and if you don't have a headache of immutability, use string builder, right? Always use string builder. Now difference between equals and double equals operator. So this equals method is in your object class, we have already talked about it, and this double equals is again an operation. So double equals operator is actually used for reference equality. So when we have an object, we have a value of that object, right? So the object refers to that value of the object through a memory address, and then there is a reference. So double equals operator checks for that reference equality, so if they are actually pointing towards a same object or not. Now usage wise, it determines if two reference point that we have already talked about to the same object in memory or not. Behavior, it does not compare the contents of the object, which is why we have equals method. So that is the basic difference. Equals check for the equality, double equals checks for the reference, if they are pointing to the same object or not. So for an example, if you want to compare two strings, you have to use equals, because string constant pool is existing there, so double equals will not work. And if you have an integer comparison, then you can use double equals operator. Alright, now there are some key points. So for primitive types, like I told you, double equals is used to compare values directly, and int is one of them. So equals does not apply to primitives because it is a method of object class, and primitive is not an object. Now string class overrides the equals method to compare the actual contents of the string, so we have to use equals. Now when we talk about custom classes, you should override the equals method. Now we already implement object class, so we can easily override equals method, and in that method you can define how do you want to compare these objects. If you do not override it, the default implementation will be used, which is equivalent to double equals. Now let's take an example of double equals and equals method. So what I will do is I will create three string basically. So str1 equals to, I will do hello, and I'll copy this and duplicate this to str2. Now in the third string, what I will do is basically I will use the new keyword to create hello again. Alright, now let's do the comparison. So to compare, what I will do is first comparison is going to be your str1 equals str2. So this one is pretty simple. Obviously this is going to be true. Right, and then str1 equals str3. This is going to be false because it doesn't check for the equality but the memory address. And now the final comparison, which is going to be str1 dot equals str3. Alright, so this should be true. Now let's run this and let's understand why this happened. Alright, so in the first case there is an reference comparison, so they both are actually same object, because when you create an object for the very first time, in that case JVM will create a hello object in your string constant pool, but for the second time it first checks if the same object is already existing in the string constant pool or not. If it is already existing, in that case it refers str2 with the existing object, so it is not creating any object. That is why we got true here. Now in the second comparison, because this is an object in the constant pool and this object in heap memory, they both are actually different object. That is why we got false here. Now equals method doesn't check for the reference but for the value that is stored in that object memory address. So in both these two different objects we have the same value. That is why we got true here. Okay, now let's tweak this a bit. So let's remove everything from here and let's simply do str1 equals str3. So this obviously is going to return false. Alright, now what if I want to return this as true? How should I do that? So to do that, what you can do is you can create another object, let's say string 4, and use str3 dot intern method. So what this method does is it allows you to explicitly intern dynamically created strings. So when you invoke the intern method on a string, Java checks if an identical string already exists in the pool. If a match is found, the intern method returns a reference to the existing instance from the string pool. If no match is found, in that case the intern method adds the string to the pool and returns a reference to it. Now while I'm using this, if I try to use this in another south system.out.println, in that case it should return true. Now let's run this. So I got false and true. Alright, so now let's move on to the next question. Now finally finalize. So these are not actually tricky questions, so we already know everything about it, but there are some tricky questions on finalize, so we will talk about it. So what is final? Final is a keyword. It can be used on a variable, it can be used on a method, it can be used on a class. So when you use it in a variable, then the variable is a constant. If you use it in a method, as in method declaration, that method cannot be overridden. Now final classes, it means that it cannot be subclassed, as in it cannot be inherited. So what is the purpose of using final? Final defines constants and prevent method overriding and inheritance. Now finally is basically used for your exceptional handling. So when you use try catch, you want to use finally because you want to close something before you actually throw back the exception, because when you throw the exception, your program exited, and before your exiting of the application, you want to ensure that these steps or these particular instructions happens before actually the application is exiting. So the purpose is to ensure that a block of code is executed after a try block, regardless of whether an exception is thrown or not. Now here, if you use system.exit, then finally will not execute, right? Remember that. Now what is the uses here? It is used in exceptional handling to execute code that must run whether or not an exception occurs, right? Now finalize is very vast, right? So it allows an object to perform cleanup before it is reclaimed by the garbage collector. So where do we use it? The finalize method is called by the garbage collector on an object when there are no references to it. This is used to release resources or perform cleanup operation. Now can we call it on our own? So yes, we can. Now important note, the use of finalize is generally discouraged in favor of other resource management techniques. I have put this line specifically for this, as it is unpredictable and may not be called promptly. So a lot of people think that if you want to, let's say if you have a multiple objects initialized with null, or if you are done with those objects, you have initialized or you have set the value null of those objects, and then you call the finalize method thinking that the garbage collection will happen immediately and then you have the free memory, but it doesn't work like that. So you shouldn't anyway use this finalize method. So you cannot even think like when actually it is going to be called out, right? There is no guarantee, so don't use it. So if someone or if an interviewer asks you should you use finalize method, so the answer is no. Why? Because we are not sure when it is going to be called, because that is the responsibility of your garbage collector. Alright, now to summarize, final is used for constant, preventing method overriding and preventing inheritance. Finally is used to ensure code execution after a try block regardless of whether an exception occurs. Finalize a method that allows for cleanup before an object is garbage collected, but it is generally considered unreliable and less preferred in modern Java programming. Now the last question, what is marker interface? So we have already talked about clonable interface before when we talked about the object class key methods. So marker interface in an interface which doesn't have any methods. So it is a special type of interface. Its primary purpose is to just indicate that a class implementing this interface has a certain property or should be treated in a special way by the Java runtime or other libraries. So why should we use marker interfaces? So if we want to convey metadata or specific behavior characteristic to the Java compiler or runtime system, we can use marker interface. Also, you can use it to indicate a special behavior, like if you want to inform other parts of the application that the implementing class should be treated differently. For example, serializable interface is a marker interface used to indicate that the objects of the class can be serialized. Also, we talked about metadata, so it serves as a way to attach metadata to classes. For instance, the clonable interface indicates that a class supports cloning. Alright, so it can be cloned. An object of this class can be cloned. Now, how marker interfaces work when they actually don't have any concrete methods? So marker interface typically do not have any impact on their own. Instead, they are used in conjunction with reflection or specific library mechanism that check if a class implements a particular marker interface to determine behavior. So JVM basically decide if you have clonable interface, then it will look into that functionality. If you have serializable, then it will look into that functionality. So just for an example, if the Java output object output stream class uses reflection to check if a class implements the serializable marker interface. So for example, the Java already existing class object output stream uses reflection to check if a class implements the serializable marker interface before attempting to serialize an object. So this is a mandate here. If you don't use serializable marker interface, then you won't be able to serialize that object. Now, modern alternatives of using marker interface. So while marker interfaces are still used, modern Java often employs annotations as an alternate. So annotations can provide more flexibility and readability and are generally preferred for adding metadata to classes, methods, or fields. For example, you might use an annotation like entity in JPA to mark a class as an entity. So again, remember this is something beyond core Java. This is your Spring Boot, your JPA, your Hibernate, right? So just remember that there are more additional modern alternatives over this marker interface. So these were the only questions that I wanted to talk about in this video, and these are the questions that I think if you learn about it, then you are good to go for any interview, because these brush up or freshen up your basic core Java. So if you have any questions on these questions, do let me know. If you have any other question that you are troubling with, then you can also let me know on the comment section, and I will meet you in another awesome video, whatever I can think of. Or if you have any suggestion, do let me know, then we will talk about it more. Till then, stay happy, keep learning, and bye bye.